This is example 2 of lesson 4.8, Patterns and Functions, and we're talking about squares being added to each other. Squares, each 1 unit by 1 unit, are placed next to each other one at a time to form a long strip of squares. All right, it looks like this. We start with stage 0. When we start, we have 1 square, and then we add 1 square in stage 1. We add another square in stage 2. So what is the perimeter of stage 0 with 1 square? Well, perimeter of a square with a side length of 1, that's going to be 4 units. 4 units. And we could count that. 1, 2, 3, 4, easily enough. All right. What is the perimeter of the figure using 2 squares? Okay, well, let's find that out. Stage 1, 1, 2, 3, 4, 5, 6. So that'll be 6 units. And 3 squares? 1, 2, 3, 4, 5, 6, 7, 8. All right. 8 squares. 8 units. Do we notice any patterns here? All right, well, let's keep going just in case. Draw the next 2 stages in the pattern. What are the perimeters of those figures? Well, the next pattern is going to be stage 3. I'm going to put ST3, and it's going to have, 4 squares. All in a line like this. So I'm continuing the pattern exactly as much as I can. And looking at it, I go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. P equals 10 units. And then we have stage 4. Well, and that's going to have 5 squares. 1, 2, 3, 4. Yikes! I'm bad at drawing a... That's 6, isn't it? All right, let me erase that outer one. And I will fix that, shall I? There we go. 5. 1, 2, 3, 4, 5. All right, and that one has 5, 6, 7, and 11, 12. P equals 12 units. All right. All right. What is the operation that describes and change of perimeter from one stage to the next? Here I was hoping somebody would ask this. Well, we are going from, we start at stage 0 with 4 units. Stage 1 is 8. Sorry, stage 2 over here is 6 units. Stage 3 is 8. That's a little backwards. Put that in a box there. Put that in a box there. Stage 3 looks like it's 10. Stage 4 is 12. What's going up here? 4, 6, 8, 10, 12. That looks like plus 2 to me. All right. So, predict the perimeter of the figure in stage 9. So what will it look like in stage 9? Well, at stage 9, how many boxes is it going to have? It's had 1 more than the stage number since the beginning, so it's going to have 10 boxes. I'm not going to draw that. But we can write out our recursive sequence. Now, we start with stage 0 at 4. Then 6 is 1. 8 is 2. 10 is 3. 12 is 4. I'm just going to keep the pattern going. 14 is 5. 16 is 6. 18 is 7. 20 is 8. And 9 is going to be 22. Alrighty then. Now, here's the thing. Remember in example 1 when I said, oh, this here, first term, is a bit like our start value. And the operation that describes the change in the perimeter from one stage to the next is a bit like our amount of change. Well, you can write a function to represent the change in the perimeters here. And I've just written out my start value and my amount of change. So my function would be y equals amount of start value 4 plus 2x. All right, so that's my function for the number of units in my perimeter. So if I wanted to know what the perimeter was in stage 9, all I would have to do is plug in 9 for x. Y is my perimeter. Y equals 4 plus 2 times 9. equals 4 plus 18 equals 22. Bam! So I can use a function rule to do this part, this predict the perimeter, without having to write it all out like that. And it works just the same. So again, it's going up by 2. That's the same as our amount of change. It started at 4. That's our start value. I can make a function, or I can list it. When you're dealing with recursive sequences, you can do either. And that's it.